have this recorded for, okay, so this is a review of what we had done on Thursday, where we learned how to solve quadratic equations. Let's just review these two, and then we'll go on to some new material, and I'll talk about how we're going to run the midterm. Okay, so first of all, looking at this example, I realize that it's a quadratic equation because it has an x squared. We know when we're trying to solve a quadratic equation, what we have to do is make sure that we have everything on one side equaling to 0. And in this case, it seems to me to make more sense to bring this negative 100x to this side, so that where our x squared term should turn out to be positive. Usually that makes it easier to factor. If you brought the 10x squared to this side, you'd get the right answer in any case, but you're less likely to make mistakes if, since I see this is a positive 10x here, I'm going to add 100x to both sides. Then, of course, we'll make this equal to 0, and this will be 10x squared plus 100x. And once we have it equal to 0, the next step we have, this is as I said later on in the term, we'll have other methods of solving quadratic equations, but at this point, the only way we have of solving them is by factoring. And if I look at this, the first thing I always look for is a common factor, and there is a common factor, 10 for sure, and also x, because there's an x squared and an x. So I'm going to take out the 10x, and I'm going to get 10x times x plus 10 after I factor it. Once I've got it factored, then I take each of the factors, each of the things that are being multiplied, and separately set them equal to 0. So my first factor happens to be the 10x. So I'm going to set that equal to 0. And my other factor is the x plus 10, and I'm going to set that equal to 0 as well. Even though this is 10x is not in a parentheses, the only reason we may have to put in a parentheses because it was a single term, but it certainly is a factor. Here, when I'm going to divide both sides by 10, and 0 divided by 10 will give me, here, I'll go over here, x equals 0. That's my first answer. 0 divided by 10 is 0. One of the answers to this equation is 0. To find the other answer, I'm going to bring the 10 to the other side over here, and that'll give me x equal negative 10. So my second answer is negative 10. Don't forget, you usually do have two answers to a quadratic equation. In this case, the two answers were 0 and negative 10. And I see, Reggie, you got that answer. Excellent. Okay, so now let's look at the second question. We have x times 2x minus 11 equals negative 12. And truthfully, I see something that's already factored, but I can't separate it and set each of them because I don't have 0 over here. If this would have been a 0, then I could have right away said x equal to 0 and 2x minus 11 equal to 0. If I have it equal to 0 and it's factored on this side, then they've done all the work for me. But in this case, it's equal to negative 12. They've made it harder, not easier. I have to remove the parentheses. By using the distributive property, this will give me 2x squared minus 22 equals negative 12. And then I have to bring the 12 over to make it equal to 0. I'm bringing it this way because here my x squared is positive. So this is giving me 2x squared this should have been a minus 22x. Minus 22x plus 12 equals 0. And now I have a trinomial equal to 0. And again, once it's equal to 0, it's a quadratic because it has an x squared. So we're going to factor this. And again, I see in this thing, there is a common factor. In this case, the common factor is 2. So I do 2 times x squared. I did something is wrong here. I think I gave you the wrong problem.
Excuse me, Professor? Can you hear me? You can? Oh, okay.
I'm doing it wrong. I multiplied, let's go back. When I multiplied by x, I did x times negative 11 got 22. Obviously, that was wrong. Okay, thank you. Were you trying to tell me I was doing things wrong?
Oh, yes, that's what I was gonna, yeah.
Okay, thank you. Okay, I'm starting again, sorry. I have to remove the parentheses. So x times 2x is 2x squared. X times negative 11 is negative 11x. And that equals negative 12. And now I have to bring the 12 to the other side. So I get 2x squared minus 11x plus 12 equaling 0. That's what I got. And there is no common factor here because this is an 11. It's not a 22. I don't know what I was thinking there. But I want to factor this. It's a trinomial. In order to do trinomial factoring, I'm going to use the AC method. So my AC is going to be 2 times 12, which is 24. It's a positive 24. And my B is the negative 11. So first of all, since this is positive, both signs are going to have to be the same. And since the B is negative, it must mean that both of my numbers are going to be negative. And they're going to have to multiply to 24 and combine to negative 11. So let's see, what multiplies to 24? Well, 1 and 24 is not going to work. 12 and 2, when I combine them, are going to give me negative 14. That's no good. Then I have 8 and 3. And 8 and 3 work because negative 8 times negative 3 is positive 24. And negative 8 plus negative 3 is negative 11. So I'm going to rewrite this as 2x squared minus 8x minus 3x plus 4. Here's my negative 11x. In my first group, I have a common factor of 2x. So this becomes 2x times x minus 4. In my second group, the only I'm really losing it. My second group, that was a 12, not a 4. I was in my head factoring it already. I have a common factor of negative 3. And negative 3 into negative 3x is x. And negative 3 into positive 12 is negative 4. So that this factors to x minus 4 and 2x minus 3. Okay, so let's go over here. This was this one. We now have, after we've multiplied it out and factored it, we got to x minus 4 times 2x minus 3 equaling 0. Remember, we don't stop at the factoring part. We now have to go a step further. We have to set each of the factors equal to 0. So x minus 4 equals 0 is one factor, and 2x minus 3 equals 0 is our other factor. Here, I'll just add 4 to both sides, so one answer gives me x equals 4. Over here, I'll add 3 to both sides, which will give me 2x equals 3. And I have to do one more step. I have to divide by 2 to get what the x is. So my final answers are 4 and 3 over 2. And I saw some people had sent me those answers as well. So that's how we solve a quadratic equation. These are 2 quadratic equations. We'll know they're quadratic because of the x squared, and then we factor it, and after we factor it, we set each factor separately equal to 0 to solve it. Okay, let me just make a comment about what's going on from here. Basically, until here, though, is what is going to be covered on the midterm. We have one other topic that I'm going to be covering today, and it's going to be going into chapter 5. The midterm is basically chapters 1 through 4. After today's class, starting at about 2 o'clock, you will be able to have access to your next test in this course, which is test 2 for the course, but it will be called test 1 for Blackboard, because this test is not going to be on Delta Math, it's going to be on Blackboard. It's also the review for the midterm. It is a test that was going to be on all 4 chapters, similar to what your midterm is going to be like. It's also, the setup is similar to what you're going to see on your midterm. So it's not only a test, it's also a practice for the midterm. If you do better on the midterm than you do on this test, then I will take the mark that you're getting on the midterm and count that as your second test mark. In other words, whatever you got on your first test on Delta Math, that's test 1. We're now up to test 2. It's going to be on Blackboard. Let's say you get 70 on this test. And then you do the midterm and you get a 90 on the test. I will count as your test mark for test 2, your 90. In other words, it will show me that you've done better, and therefore I'll consider that as the better mark. Again, your midterm is going to be next week. I think I'm going to schedule it for Thursday after class, and I'll probably give you through Monday morning to complete it. I will send you an email in terms of the exact timing of the test, but that's approximately what it's going to be. It's not going to be during class time. I don't want to mess. We had a couple of days where we missed, so let's make sure that we have the class time to study, to do work. This practice midterm test 2 is going to be available starting, as I said, after class today. You must complete it by next Tuesday before class. Okay, I'll tell you. The test consists of 20 multiple choice questions. You do it right on Blackboard. It's really, you're supposed to have an hour for it, but I set it up that you should have 70 minutes. So if you just a little extra time, again, it's 20 multiple choice questions. Essentially, that's what the midterm is going to be like as well. it'll be an hour's test, and you will have 20 questions, 20 multiple choice questions. In other words, this is very similar to what your midterm is going to be like. It's a good experience for you, so you have an idea, because it's really the first time I'll be giving you a test on Blackboard. Again, as I said, it's due by next Tuesday, before class on next Tuesday. But once you sit down to do it, you must finish it in one sitting, just like the Delta math. Once you start, the timer goes on, and you can't go away from it and then come back 2 hours later and think you're going to have the time. Basically, you're supposed to be given an hour for it. I probably will give you maybe an hour and a quarter for the midterm, just like I'm giving you a little extra time on the practice midterm, because it again takes a little bit. Sometimes you need just a few minutes extra just to get yourself settled. So, but again, it'll be a question of, once you start it, you have to complete it in one sitting. Once the time will run out, that you will not be able to have time to do anything more on that test. Did that answer by the way, did that answer your question? I'm trying to think who had a question. Brandon, does that answer your question? That you have, as I said, okay. You will have probably 70 minutes, 70 or 75 minutes. I have to find out what I'm allowed to give you, but it'll be in that range. All right. So that's going into next week, even though the midterm is only over through chapter 4. I'm going to be starting on chapter 5 today. And what we're going to be talking about is fractions and how to deal with fractions. And we're going to see that we're going to be needing being able to factor to do those examples as well. So, number one, I just want to review something that we had done at the beginning of this chapter when we started talking about polynomials. Before we talked about polynomials, we talked a little bit about monomials. I want to review how we multiply monomials and then go from there into dividing of monomials, because that really takes us into fractions, which is the chapter 5. First of all, we had questions that looked like this. Suppose I gave you something like 3x to the 5th y squared times 2x fourth y, for example. And if you remember, when we multiplied these, we would multiply the coefficients, the numbers in front together. 3 times 2 is 6. And when it came to the variables, we multiplied them by adding their exponents. So we got x to the 9 and y. This is a 3 and this is a 1. Remember, there's no exponent written. It's understood to be 1. So that would be y third. Sometimes we have an expression like this, where we will have, let's say I have the 3x fifth y squared, and on the outside, we will have some sort of exponent. What happens when we have an exponent? Well, there are two ways of looking at this. the exponent of 3 on the outside really is telling me that I'm multiplying 3x to the 5th y squared times another 3x to the 5th y squared times a third 3x to the 5th y squared. In other words, the exponent of 3 on the outside is telling me that I'm multiplying the item, this monomial 3 times. And of course, we can do it by just multiplying the numbers in front. The coefficients 3 times 3 times 3 is 27. And we can multiply the letters together by adding their exponents. So this is 5, 5, and 5 gives me x to the 15. And y squared times y squared times y squared, 2 plus 2 plus 2 is y to the 6th. And my answer turns out to be 27 x 15 y 6. Now, that works pretty well because the exponent here was 3. But what if my exponent would have been 10? Then I'd be in a pickle because I'd have to multiply something 10 times. So I want to show you a shorter way you could do this when you have an exponent on the outside. You'll see we'll come out with the exact same answer. When you have an algebraic expression, a monomial, raised to an exponent, what you have to do is distribute that exponent to each one of the multipliers, to each one of the factors. In other words, I'm going to have to do 3 to the 3rd power, x 5th to the 3rd power, and y squared to the 3rd power. Each one of these factors of this monomial is being raised to the exponent of 3. Well, 3 to the 3rd, we know is 3 times 3 times 3, which is 27. If you really had a question, you could stick it into your calculator. You do in your calculator have an exponent button. Mostly on your calculators, the exponent button looks like this. A little arrow head pointing up, because that's the symbol that's used for exponents when you type as well. Okay, so you could do 3 exponent 3. You will get the 27. When it comes to the variables, when you have a number with an exponent raised to a second exponent, what you do to those 2 exponents is you multiply. So 5 times 3 is 15. So this becomes x to the 15. And 2 times 3 is 6. So this becomes y to the 6. And notice we got the exact same answer, but it's much quicker. So this is what's called distributing an exponent on a monomial. Now, let's say, I'm going to do a few examples, and once I get to I'm going to give you some to try. Let's say you had a monomial divided by a monomial. Let's say I had something like negative 4 x6 y squared over 2x cubed y. What if we have a fraction that consists of a single term over a single term? How do we simplify this? How do we make this in lowest terms? So what we do is we compare the coefficients. then we deal with the x's, then we deal with the y's. So first of all, between -4 and 2, of course, we can cancel out 2. So -4 divided by 2 is -2. 2 divided by 2 is 1. Now, I don't put in the 1 unless everything disappears. If all my denominator disappears or all my numerator disappears, then I'm going to have to put in the 1. But as I'm doing each term, I just cancel out the like factors. Okay, now go to the variables. So with the x6 and the x cubed, when you're reducing, you always are going to cancel out the lower exponent one, which in this case is the x cubed, and subtract that exponent from the higher one. So 6 minus 3, because when you're dividing, you're subtracting exponent. 6 minus 3 is 3. So I'm left with an x to the third. Notice I cancel out the lower one and I subtract it from the higher one, which means that my higher exponent, my answer, my term that I'm putting down will always be in the position where the higher exponent was. Now we have y squared and y. Now remember, y alone means y to the 1. So the lower exponent is y to the 1. It gets canceled out. Minus, look at, everything was canceled out from the bottom, so I better put a 1 there. And 2 minus 1, this exponent minus this exponent is 1. So this becomes y to the 1, or just y. So then my final answer became -2x cubed y over 1. Now, when you get an answer where your denominator is 1, when the bottom is 1, you don't have to put it in. You could just write your answer as -2x cubed y. If the numerator is 1, if the top is 1, you've got to leave it. But if the bottom is 1, you don't have to put it in. Okay. Now, sometimes we're going to see that we might have some strange looking exponents. You could have exponents that are 0. You could have exponents that are negative. You can even have exponents that are fractions. Okay, we're not going to deal with the fractional exponents today, but we are going to talk about what happens when we have either negative exponents or 0 exponents. And then we're going to put the whole thing together and do examples that have any kind of exponents at all. So first of all, anytime you have an exponent that's 0, and that, remember, when no exponent is written, it means the exponent is 1. If you have an exponent of 0, the 0 will definitely show up. But what it means is just the plain number 1. Anything to the 0 exponent, even 25 x fifth y 75, if there's a 0 on the outside, it doesn't matter how complex it is, it's equal to the number 1. So that's the first thing. 0 exponents mean 1. What about a negative exponent? What does it mean when we write, for example, x to the -5? So I'm going to give you an explanation, and then I'm going to show you an easy way to deal with it. When you have a negative exponent, what it really means is you're taking the reciprocal of the number. That's the definition of a negative exponent. X to the -5 doesn't mean you're multiplying a number or -5 times. That absolutely doesn't make sense. How can you do that? What it means is that you're taking the reciprocal of your number and you're making your exponent positive. In other words, it means it's 1 over x to the 5th. So we have to keep in mind every time we see a negative exponent, what we're going to be doing is taking reciprocals. So let's say I had an example that looked like this. Four x to the negative 6, y to the third, and we're raising this to the negative 2 exponent. Okay? What in the world does this mean? What we really want to end up is an example that's reduced as much as possible and that all our exponents are positive. So here's how I think. It's not the only way to deal with it. If you know how to deal with these and you've done this before and you like your method, fine. My method, it may sometimes take a little bit longer, but if you do the steps always in the same order, you will not make mistakes. It's a little bit of an organized method. As soon as I see something that has a any kind of negative exponents, the first thing I know is I'm going to have fractions. So that's the first thing I do. I put in a fraction. In this case, there's nothing in the denominator, so my denominator in this case is just 1. We're starting out looking at this example, and it's really over 1. The first thing I want to do is take care of the parentheses. And usually, whenever we have an expression that has in a parentheses, we try to deal with the parentheses first. And we know in order to deal with the parentheses, we have to distribute the exponent that's on the outside to each of the factors on the inside. Don't forget, 4 is part of it. We have to do 4 to the negative 2, x to the negative 6 to the negative 2. Now remember, this has an exponent. When you have 2 exponents on the same number or letter, what you're going to do to those 2 exponents is you're going to multiply. So you're going to multiply the negative 6 times the negative 2, and that's going to give you x to the positive 12. Then you're going to do the y to the third to the negative 6. So you're going to multiply the 3 times the negative 2, and that's going to give you y to the negative 6. It's y to the third to the negative 2. Your 3 times negative 2 is negative 6. And this is all over 1. Step number 1. Remove your parentheses by distributing the exponent that's on the outside. Step number 2. Remember, we wrote this as a fraction. What we're going to do is take the reciprocal of any letter or number that has a negative exponent. We know a negative exponent means take its reciprocal. If it's got if it has a positive exponent, we don't have to take its reciprocal. So what does it mean, take a reciprocal? Here's my fraction. What do you do when you're taking the reciprocal of a fraction? Whatever is in the numerator goes to the denominator. Whatever in the denominator goes to the numerator. So I'm going to look at each one of the factors, the first one being 4 to the negative 2, and decide, should I move it from its position? In other words, should I take its reciprocal, or should I leave it where it is? So 4 to the negative 2 has a negative exponent. It happens to be in the numerator. I want to put it in the denominator and make the exponent positive, because that's what taking a reciprocal tells us to do. The next thing I see is x to the 12. The exponent here is positive, so I don't want to take its reciprocal. I'm going to leave the x to the 12 on top. And the last thing I see is a y to the negative 6. Its reciprocal is negative. It's on the top. It's going to have to go to the bottom. Notice there's a 1 in the bottom, but 1 times anything is that number. So now all I have to do is change this 4 squared into a 16, and I get x to the 12 over 16y6. I can't reduce anything because this is an x and this is a y. But if you notice, basically, after I remove the parentheses, the first thing I do is I switch anything that has a negative exponent, take its reciprocal by moving it from its position and making the exponent positive, so that ultimately all I have is positive exponents to work with. That makes it a much simpler example to do. Here, let's see if you could do this example. I'm going to give you one to try. And then we'll do one more after this. (36 x fourth y seventh) over negative 4 x 5 y negative. See if you could simplify this so that you'll end up only with positive exponents. No, I'm taking attendance a little bit later. Okay, I think you had enough time for this. Again, there are no parentheses here, so I don't have to do anything with parentheses, but I do have to see what to do with this thing that has a negative exponent. And actually, I'll just rewrite it as 36 x fourth y 7. I'm leaving all of that the same place, and the negative 4x fifth I'm leaving. But this y to the negative 8, I'm bringing the y to, I'm bringing it from the denominator up to the numerator because it's got a negative exponent. I have to take its reciprocal, which means anything that's on the bottom goes up on top, anything that's on top goes on the bottom. Okay. So now let's see what we can do. The 36 and the negative 4 could certainly be reduced. divide both top and bottom by -4, and I'll get a -9 on top, and this will cancel out. The x fourth on top and the x fifth on the bottom, I will cancel out the one with the lower exponent and do 5 minus 4, which is 1. So get x to the 1, or just a plain x in the denominator. The y to the 7, the y to the 8 are both in the numerator, so when I'm going to multiply them, I'm going to add their exponents, so that'll give me y to the 15. So my final answer becomes -9y to the 15 over x in the denominator. Notice I simplified it because I don't have so many different terms, and I'm left only with positive exponents. When we're simplifying, we don't want to have negative exponents in our answer. If it's possible, we want to get rid of the negative exponents. Okay, let's do one more, and then I saw a few people did get that answer. It's still very good. Let's try one that's a little harder. Suppose I have x -2y8 to the 4th power over x 4th y -3 raised to the 2nd power. So I'm going to do this one, and then I'll give you one to try. Okay. Parentheses. First thing we want to do is remove the parentheses. So in order to remove the parentheses, we've got to distribute the exponent that's on the outside. So in both cases, the coefficients here are 1, so that makes it a little easier. I don't have to do anything with those numbers. So x in -2 to the 4th power gives me x to the -8. Y to the 8th to the 4th power will give me y to the 32. Remember, we're multiplying the exponent. And here we have an exponent. If this whole thing would have been a 4 on the outside, then I would have done the 4 to the bottom as well as, but here on the bottom I happen to have a 2 exponent. So this is x to the 8th and y to the -6. So we distributed the exponent on the outside so that we're left without any parentheses. But we are left with negative exponents. So that's the next thing I would like to take care of. So I have an x to the -8. That's on top. Since it's a negative exponent, I have to move it to the bottom, and it becomes x to the 8th. The next thing I have is a y to the 32. That exponent is positive, so the y to the 32 stays on top. Going to the denominator, the next thing I see is an x to the 8th. That exponent is positive, so it stays where it is. Whereas the y to the -6, that has to be moved. It has to be, to take its reciprocal, you've got to move it up to the numerator. Now we can combine anything, since these are both y's, we can combine them. Adding 32 and 6 gives me y to the 38. And here we have 2 x's, and adding those, we get x to the 16. There's no reducing here because there are only y's on top and only x's on the bottom. And this would be your final answer in simplest form. So again, if you notice, he did the same thing. I first removed the parentheses by distributing the exponent on the outside. I then took care of the negative exponents by moving any term that had any, actually, you should call it factor, any letter that had a negative exponent, it got moved. If it had a positive exponent, it stayed in its position. But if it was negative, it moved because a negative exponent indicates that you're taking a reciprocal. And then the final step is to combine any letters so that you were only left with the letter once in the example. Okay, here's one for you to try. While you're doing this, I will take attendance. Let's say you have this example. X -3, y -5 squared over x -4, y cubed to the fourth power, to the -4 power. See if we can simplify this as much as we can. Listen for your name in the interim. Maury. Maury here. Hi, good afternoon. Chelsea. Chelsea here. Ariana.
You know my name? This is Chelsea.
Chelsea, is that you?
Yeah.
Hi, okay.
Hi.
Ariana is here. Good
Okay.
afternoon.
Thank you, Ariana. Have a good day. Adina.
I'm here.
I know you're always answering my questions, so you know you're here. Lachey. Lachey here. Kava. Kava was the first person here, so he must be here. Terrence.
Good afternoon.
Hi. Karide. Karide.
Here.
Hi. Kizia. Kizia here. Faith. Faith. Ethan.
Here.
Hi. Isabella.
Here.
Hi. Serenity.
Here.
Hi. Reggie, I see Reggie, you answered.
Yeah.
Hi. Zamia. Hi. Brandon.
Here.
Hi. Michaela.
Here.
Hi. Seraphine. Seraphine,
Here.
hi. Marissa,
Here.
hi. Renee, I know you asked before, if now I took attendance. Sky,
Hello, Sky Powell is here.
I see you're here, thank you. Jaden Roberts. Kennedy,
Here.
hi. Alicia,
I'm here.
hi. Natalia,
Here.
hi. Michael. Michael here?
Here.
Hi, okay. You sent me a text before I saw. Cassidy. Hi. Megan.
Here.
Hi. Kalia. Lauren.
Here.
Hi. And Kayla. Kayla Zachary. Okay. All right, let's see if we can do this now. Michael, I saw you were here. I think you asked me before. I marked you here. Okay. So again, we're going to distribute those exponents on the outside. So for the top, I'm gonna get x to the -6, I'm just multiplying, and y to the -10. And on the bottom, I'm gonna get x to the +16, because I have a -4 and a -4, and a y to the -12. So now I have my everything out in the open, no parentheses. So I look at each factor individually. X to the -6, that's going to have to be moved to the denominator, so it'll become next to the 6. Y to the -10 is also going to have to be moved to the denominator. It's going to become a y to the 10th. X to the 16th is going to stay in the denominator because it's got a positive exponent. But y to the -12 is going to have to go to the numerator because its exponent is negative. So now all my exponents are positive. I'm going to combine the x6 and the x16. And that'll give me on my denominator an x to the 22. But with the y's, I'm going to have to cancel out because one's a numerator and one's a denominator. I cross out the one with the lower exponent. I do 12 minus 10 is 2. So it leaves me a y to the 2 on the top. So my answer comes out to be y squared over x to the 22nd. And let's see if I saw there were a bunch of answers. Why, and it looks like those are the answers that we got. Reggie, it was not 22x, but x to the 22, but I think that was just what you meant.
Yeah. Sorry about that.
I know it gets a little complex when you want to type what is not basically a mathematical typewriter, but that's how you would do these things. So we've learned how to deal with monomials, even when the exponents are negative, even if the exponent is 0. And we've learned how to deal with multiplying them and dividing them. And basically, we've been working with fractions. So I want to go on with that topic of working with fractions and just start on chapter 5. Again, I'm going to be continuing with chapter 5 on Thursday. The chapter, it is not part of the midterm. The midterm does not include what I'm going to be starting now, but we can't just wait until after the midterm. The midterm, again, as I said, is going to be given from starting Thursday afternoon until Friday afternoon. You'll be able to pick a time that I'll give you a 24-hour period in which to take that test. But again, remember, once you start the test, you must finish it in one sitting in a 70-minute period. And again, right after class at about 2 o'clock, if you go to your CUNY Blackboard Math 136 account, you will see the test number 2, which I'm calling test number 1 for Blackboard, posted. It is a preview for the midterm, but it's the second test you're going to be taking. It is considered a test. It's not just homework, it's a test. And it's set up just like the midterm is. And the due date is next Tuesday. You have to complete that again by next Tuesday. I'm giving you a longer period of time to do that. It's basically, even though I'm going to probably give you some more homework on Delta Math over the weekend, it will be part of your homework is to do that test. And it has to be completed by next Tuesday. We saw that we can deal with fractions with monomials, and we saw how to reduce those fractions, how to simplify those fractions. Let's see how we handle algebraic fractions that have polynomials in them. What if I gave you something like this? This is what we call a rational expression. That's what we call these algebraic fractions, where the numerator and the denominator are both polynomials. And the question is, how do we deal with polynomials in this case? If you recall, if you had something like, say, like 24 over 40, and you wanted to reduce that fraction, you would try to find a number that goes evenly into both the numerator and the denominator, and you'd like to find the largest number that you could do. It's called finding the greatest common factor. If you notice, 8 is both a factor of the numerator and the denominator. In other words, what you're dividing out what you, in your mind, you're probably doing it in your head, you're doing 24 divided by 8 will give me 3, and 40 divided by 8 will give me 5. So my answer is going to be 3 over 5. But if you think about what you were really doing, is you were rewriting 24 as 3 times 8 and 40 as 5 times 8. And you see that 8 is a factor of both the numerator and the denominator. Both the numerator and denominator are 8 times some number. So you cancel out the common factor of 8 and you're left with 3 over 5. Basically, when you're trying to reduce fractions, that's what you're doing. You're reducing it by canceling out the greatest common factor in the numerator and the denominator. Now, how does that work when you have polynomials? Well, the key word there is factor. You have to find a common factor of the numerator and the denominator. And when you have polynomials, in order to find this common factor, you have to actually do the work of factoring. So you look for your factors of your numerator, and that's why we had a whole chapter on factoring. First of all, you look for a common factor, but there is no common factor. So in the numerator, since it's trinomial, you're going to use the AC method. And if you notice, your AC is going to be 1 times -6, which is -6. And your B is -5. So you're looking for 2 numbers that are going to multiply to -6, which means one's going to have to be positive and one's going to have to be negative in order to get a negative answer. And the numbers that multiply to 6 are either 1 and 6 or 2 and 3. But if you notice, 1 and 6 work, because if you combine a +1 and a -6, that'll give you your -5. So rewriting the y squared, that'll be y squared minus 6y plus y minus 6. Because -6 and +1 give me -5. And that gives me y times y minus 6. Plus, there's no common factor here, so I have to put a 1. 1 times y minus 6. So this gives me, for my numerator, y minus 6 and y plus 1. That takes care of the numerator. What about the denominator? I'm just going to put an X through here because I finished with that. My denominator, again, does not have a common factor, but since it's only 2 terms, the only possibility to factor it would be if this is what we call the difference of squares. And it is. This is y times y. This is 1 times 1. So I can factor that into y plus 1 and y minus 1. Don't forget, 1 is a perfect square. It's 1 times 1. Once everything is totally factored, then you can go ahead and cancel out the like factors, the greatest common factor. And when you're dealing with binomials, in order for it to be a like factor, it has to be identical. And if you notice, I have a y plus 1 on the top and a y plus 1 on the bottom. Do not make the mistake of canceling out a y plus 1 with a y minus 1. They have to be identical. So this is a y plus 1 with a y plus 1. So my final answer becomes y minus 6 in the numerator and y minus 1 in the denominator. Now notice I didn't bother putting in the parentheses anymore, because once there's only a it's as if it's in a parentheses, but since it's on the top and it's all by itself, you don't have to write in that parentheses. So that's how you deal with simplifying or reducing a fraction that consists of a polynomials. Okay, let's see if I can give you another example to try. Okay, let's do this one. I'm going to give you this to try on your own. Suppose I gave you 20y squared minus 45 in the numerator. And the denominator is 10y squared minus 5y minus 15. I'm going to give you a few minutes to see if you could simplify this rational expression. Remember, you have to factor everything first. Okay, because yeah, I see you. Okay. Okay, I see that some people already have the answer. Thank you, Reggie. So let's work on this together. Obviously, the first thing we want to do, since I see they're polynomials and I want to reduce this fraction, is I've got to factor. And with all things, my first thing, type of factoring that I always look for is a common factor. And I notice this is a 20 and a 45 has a common factor of 5. So I can put the 5 on the outside. That'll give me 4y squared minus 9. I always like to put a line through something that I'm not using anymore. And now I look at the binomial inside the parentheses, and it is the difference of squares. So I can factor that further into 2y plus 3 and 2y minus 3. So I ended up with 3 factors, 5, 2y plus 3, and 2y minus 3. Okay, let's look at our bottom. Now notice in the bottom, I also have a common factor of 5. If I take out the 5, I'll be left with 2y squared minus 1y, or you could just write it minus y, minus 3. And since this is a trinomial, I'm going to try and factor it using the AC method. So the AC is 2 times negative. Remember, I'm not using the 5 anymore. I do 2 times negative 3 is negative 6. And my B is negative 1. Again, since the AC is negative, it means one number is going to be positive and one number is going to be negative. And I need the numbers to multiply to 6, but when I combine them to give me negative 1, I think it's obvious that it's 2 and 3, because positive 2 times negative 3 will give us a negative 6, and positive 2 plus negative 3 gives us our negative 1. So this will become 2y squared plus 2y minus 3y minus 3. And this gives me, has a common factor of 2y. So this is 2y times y plus 1. And this is negative 3 as a common factor, and that's also y plus 1. So this gives me y plus 1 and 2y minus 3. Don't forget that 5 from before. Bring that down. So let me do this. Let me just rewrite what we have now. After I finished factoring, I have a 5, a 2y plus 3, and a 2y minus 3 in the numerator. And in the denominator, I have a 5, a y plus 1, and a 2y minus 3. And now that it's completely factored, I can now figure out or cancel out the like factors. First of all, the 5 on top and the 5 on the bottom just cancel. Now I have a 2y plus 3, but I don't have a 2y plus 3 on the bottom. I only have a 2y minus 3. Do not make a mistake of canceling this now. But this 2y minus 3 and the 2y minus 3 can cancel. Notice for the cancel those binomials, they have to be identical. You can't do it piece by piece. You have to deal with the whole expression. So that my final answer comes out to be 2y plus 3 in the numerator and y plus 1 in the denominator. So that's how we deal with rational expressions, algebraic fractions, when we have polynomials in either the numerator and the denominator. Again, with monomials, you can do it each piece by piece, because each of them is a factor. But with the polynomials, you cannot separate because you have to make sure they are factors that you are canceling out. Okay, all right, let me reiterate where we're up to. We're now up to working on chapter 5. We will be continuing chapter 5, which is the chapter on fractions. We're going to be talking about adding and subtracting and multiplying, dividing fractions, and solving equations with fractions, which we've done a little bit before, but now we're going to do it much in a much more advanced method. The midterm is next week. Again, I'm going to probably set it up so that you can take it either Thursday afternoon through or Friday morning or anytime. You can do it Thursday night if you want to do it. I will give you a 24-hour period in which for you to take the exam. So there should be a time that you're available to do it. It's not going to be during class time. It's going to be at your own, when it's convenient for you in that time period. Again, it's going to be on Blackboard. In addition, you have test 2 on Blackboard, which is a preview to the midterm. It's 20 questions, 20 multiple choice questions. You have any time between now and next Tuesday to complete it. On Tuesday, we will go over the questions I think need some review. Again, you can do it at any time that's convenient for you. Don't forget, once you start it, you must complete it in one sitting. You can't go and close it and then pick it up again, because it'll just stop the exam, and that'll be your mark. That's what happens as well on Delta Math. So make sure you have a time where you can sit at it and spend the time that's needed to take this test. Okay, and also keep looking on Delta Math to see if there's any homework that you might have. Okay, I'm going to say have a good afternoon. I'll see you again on Thursday, whereas again we'll continue with what we are doing.